Your phone recognizes your face, Google translates languages instantly, Netflix knows what you want to watch, and self-driving cars navigate traffic. These all use neural networks, but they're not all the same type. Just like there are different types of hammers for different jobs, there are different types of neural networks for different problems. Why different types? Think about a toolbox. You wouldn't use a hammer to tighten a screw, right? Each tool is designed for a specific job. Neural networks work the same way. Some neural networks are great with pictures, others excel at understanding language, and some are perfect for predicting what happens next. Today we'll explore the 6 main types and learn when to use each one. We'll cover feed-forward, convolutional, recurrent, radial basis function, self-organizing, and modular neural networks. Don't worry about those big names. I'll explain each one using simple examples you already know. Type 1. Feed-forward neural networks. Let's start with the simplest type. Feed-forward neural networks. Think of this like a factory assembly line. Information enters at one end, moves through workers in the middle, and comes out finished at the other end. In a feed-forward network, data travels in only one direction, from input to output. No going backward, no loops, just straight through like cars on a highway. Here's a perfect example. Email spam detection. You type an email, it goes through the network layer by layer, and out comes an answer, "This is spam," or "This is not spam." Simple and direct. Feed-forward networks are used for basic classification tasks, sorting emails, recognizing handwritten numbers, or deciding if a medical test is positive or negative. They're like the Swiss Army knife of neural networks. Not fancy, but reliable for many jobs. Type 2. Convolutional neural networks. Next up, convolutional neural networks, or CNNs. These are the champions of image recognition. Imagine you're looking at a jigsaw puzzle through a magnifying glass, examining small sections at a time. CNNs work exactly like this. They use special filters that slide across images like a magnifying glass. The first filter might look for edges and lines. The second combines edges into shapes. The third recognizes complete objects. Think about how you recognize a cat in a photo. First, you notice pointed ears, then whiskers, then put it together. That's a cat. CNNs do the exact same thing, just with mathematical filters instead of eyes. CNNs power facial recognition on your phone, help doctors spot diseases in X-rays, and let self-driving cars see pedestrians and traffic signs. Anywhere you need a computer to see and understand images, you'll find a CNN. Type 3. Recurrent neural networks, RNNs. Recurrent neural networks, or RNNs, are like having a memory. Unlike feed-forward networks that forget everything after each decision, RNNs remember what happened before. Imagine you're reading a story. To understand each new sentence, you need to remember what happened in the previous sentences. RNNs work the same way. They keep notes about what they've seen before. When you're typing on your phone and it suggests the next word, that's an RNN at work. It remembers the words you just typed and predicts what might come next based on patterns it learned from millions of text messages. RNNs are perfect for anything that involves sequences, translating languages, powering voice assistants like Siri, or even predicting stock prices based on past trends. They're like having a computer with a really good memory for patterns. Type 4. Radial Basis Function Networks, RBFs. Radial Basis Function Networks, or RBF networks, work like finding your tribe. They group similar things together based on how close they are to each other. Imagine your school cafeteria. Sports kids sit together, music kids sit together, art kids sit together. RBF networks create these invisible circles and say, if you're close to the sports circle, you're probably into sports. These networks are super useful for power companies. When there's a blackout, the RBF network looks at which power lines are connected to each other and figures out the best way to restore electricity. It groups related power stations together and fixes them as a team. They are also used in medical diagnosis, grouping patients with similar symptoms to predict what treatment might work best. Type 5. Self-organizing neural networks. Self-organizing neural networks are like Marie Kondo for data. They take messy information and organize it into neat, logical groups without anyone telling them how to do it. Imagine if your messy bedroom could organize itself. Books would group with books, clothes with clothes, games with games, all without you giving any instructions. That's exactly what self-organizing networks do with data. Doctors use these networks to analyze patient data. The network might discover that patients with certain combinations of symptoms tend to respond well to specific treatments, patterns that humans might never notice. Companies use them to understand customer behavior, finding hidden patterns in shopping habits that help them create better products and services. Type 6. Modular neural networks. Think of a hospital. One department handles your heart, another your brain, another your scans. Each works independently, but together they give a complete diagnosis. Modular networks do the same with data. In autonomous drones, one module might process vision, another handles movement, and a third makes decisions. Each module is trained separately, but they collaborate in real time. Modular networks shine in complex systems like robotics, where multitasking is essential. They're efficient, scalable, and great at handling diverse inputs without overwhelming a single network. So there you have it, 6 types of neural networks, each with its own superpower. From recognizing faces to predicting stock prices, these networks are quietly shaping the world around you. Just like tools in a toolbox, the right neural network depends on the job. Whether you're building apps, analyzing data, or just curious about how AI works, knowing these types gives you a powerful edge. If you found this helpful, hit that like button, subscribe for more AI breakdowns, and drop a comment. Which neural network surprised you the most?